Okay, so we are back for fifth video, right? Second video. Okay, we saw how to write hello world, and let's go back to this terminal, right, where we run the program. If I now run, not this one, sorry, I need the other terminal. And it's going to be a little bit confusing because now we have the CMD, we have the git bash, and we have the editor. I think we are going to reduce this quite soon because in the git bash now I type in git status, and I see that there is the folder, the day 2, and the plans have changed a little bit. What did I change in the plans? Do you remember? How do I check it? Git diff, right? And then it will show me that this is what I changed. It says that I removed this line and added this one, but in reality, what happened is just I added the link here. Okay, that's fine. Okay, so I can say git add plans, and I say git commit add link. Okay, and on the other hand, I say git add dot, and I check out git status because I would like to know what did I add. So I said add everything, and it added, put the in the staging the folder day 2 with this hello world file. Okay, git commit first example. Okay, and partially what you can see is that the way I program is quite often I do these commits. Basically, every time I have something a little bit working, I didn't ruin too much, okay, whatever, then I make a commit, and I even push it out. For now, I push it out so you can see it already. So we can go now in the browser, if I find the right browser again. This one. Okay, I don't need this window anymore. I don't need this window anymore. Neither this one, neither this one. So I can reload this. So now if I go back to the top, it still doesn't show, of course, the day 2. If I press Ctrl R, now it shows the day 2, and here is the file. Okay. So you can see the file. You can also clone the repository. So you could also clone this repository by my repository by coming to this green button and clicking on it and copying the repository either with the probably this SSH it's fine. Okay, and then you can have it locally. And every time I make some changes, you can come in and type in, actually I'm going to show you this, okay? Before we continue with the programming, I'm going to show you this. So what happens if someone somehow changes the repository here on GitHub? Not locally, not I changed it locally, but somehow this is changed. For example, if multiple people work on the same repository and someone makes some changes on their computer, the other person, and they push it out, okay, here. I don't have that change locally yet, right? It's just in on GitHub. So how do I get those changes? So let me make a little change here. I go to this plans file and I edit it. And I'm going to change it on GitHub as if someone else made the change. And what I would like to do is, okay, let's hello world. It's in the day. I'm just typing in. It's the day 2/hello world.py file. Now I also put these backticks here. That's in Markdown. It will show really nice. Okay, so I commit the change, update plans, fine, commit the change. Okay, Now you can see this is the color, this is a slight emphasis that we get because of the backticks. It's used for, these backticks are used when you have some code example that you would like to show what they call verbatim. Okay, so now I have some changes here on GitHub, but they are not locally yet. So if I come here somewhere to the editor, it's not here yet. Okay. So what now I can come to the git bash, okay, and type in git pull. And before I press it, let me explain when is it going to be useful for you. So let's say you decide you would like to have a copy of the repository of this course on your computer. So you go ahead and come here, go to the main page, take the link, this one, and on your computer you type in git clone with this address, and then you will have this on your computer. And I then update it because we make progress. I add more files. Next week you would like to update it. Now, instead of cloning it again, what you need to do is come to your folder and then type in git pull, and it will pull down the changes, only the changes, not the whole thing again. Okay. Now, in our case, it's not such a huge difference because the whole repository is really, really small. But sometimes these repositories are quite large. Sometimes they take minutes, many minutes to clone. So you don't want to clone it every time. You just want to get the updates. So this is what happened. And if I come to the editor now, I think it automatically updated itself. So the editor noticed that the file changed on the disk and updated it. Now, what happens if you are really, really two people working on the same project and you're both making changes? Well, that's a whole separate story. That's when what we call merging comes in play, or sometimes they call it rebasing. But the main idea is these two techniques, basically, on how to combine the two changes. So let's say I made these changes and someone else adds some more text here in the assignment, okay? Then fine, Git is able to combine these changes automatically. The only real problem is if, well, not the only, but one of the problems is if we both change the exact same line or very close to each other. And then Git says, okay, I don't really know which one you want, okay? If I change this line and you also change the same line and did something else, how could Git decide which one is the correct one? So then you will have to do some manual merging. It's more like a little bit background explanation because for now, at least, you won't work two people on the same project in this way. Well, it's good to know that it can handle it. Okay, so I wanted to show this, and I wanted to go on with the programming part. But before I do, let me ask if anyone still has questions with the installation and with the things that we learned so far. So we make sure that everyone is on the same page, basically, that you all have Python installed on your computer, and you could all run Hello World. Basically, that's usually I spend a lot of time on this. So even if you haven't got there yet, please do it in the break or whatever. So you will have to, so each one of you will finish today with a working Python installation, with a working Hello World program, okay? So you won't, because that's that's a place where I can really help live, okay? Those people who are watching the videos, well, they will have to do it on their own, or they might ask you on the WhatsApp group. and so on. They might send me an email, but again, it's much easier to do it live, looking at the computer of the other person. Okay, so let's go on. Any questions, really, before I go on? Anyone needing help? Okay, so let's go on with a couple of more of these assignments, and then yeah, I know what else I wanted to. Okay. So we had this program called Hello World, right? I run it Python, Hello World. But let's say now we would like to welcome some person. Okay, so say hello Gabor, or hello Fu, or hello Mazalo, or I don't know the names of other people. Just I remember yours now. So I create a new program. But basically, what I would like to do, I'm going to create a new program. Okay, let's say Control N, new program, and I start typing in. The way I can do is that I need to ask the user some input. Okay, I need to ask the user what is his name. Actually, before that, let's do step by step. Let's say we have a person, and the name of the person is Fu. And we would like to print out the name. Okay, name. So what we have here, name. Interesting. It's already noticed. It thinks that it's a Python. Because I did it. No, I didn't give it the name. It's untitled. It doesn't know what it's called. It somehow figured it out. It's Python. I don't know. Whatever. So let's save it. Control S, and I save it. Hello person. Bye. Okay. What I did here is it created a variable. Basically, a lot of the programming is about taking values and doing all kind of calculations on these values. The calculation might be numerical calculations, adding them, multiplying them, whatever. It might be text manipulation, but basically we always have to create variables, places basically where we can put in these values, and then we change these values. So that's why they are usually called variables. The way Python does this is that you type in the name of the variable, which in this case it's called name, slightly confusingly. Let's call it differently. Let's call it first name. Okay, first name. Okay, now it may be less confusing. Okay, so this is the name of the variable, that equals sign, and then whatever I would like to put in there. I don't need any specific thing to declare that I have a variable, as some other languages might need. And for those who have a bit mathematical background, this equal sign doesn't mean, like in mathematics, that these two things are somehow equal. This is called as an assignment. So this first row basically says, take this foo string, the foo text, and put it in this variable I just created called first name. Now you see that I put quotes around here. If I don't put quotes around, then let's put it this way. You will see these curly things here. Now let's press F8. I haven't tried it here in Python yet. Okay, so F8 shows the errors that Python would give you. Okay, that's one of the nice parts of the editor. Okay, so I pressed F8, and if you are on a notebook, then please note that you probably have to press the function key and F8, because the F8, without that, then it goes into airplane, flight mode, and then it will turn off your connection to Zoom, which happens sometimes to me if I am not doing it properly. So before I'm showing this F8, I wrote some code here, said first name equal to foo, and I didn't put the quotes around. What happens if I run this program? So I go to this command line and I say Python, hello, and it auto-completed to the hello person, enter, and then this is what it says. It says name error, name foo is not defined. Okay, one small thing, you see this whole thing that like we have like 4, 5 rows here of the error message. I am reading from the bottom up because at the end you get the most specific message. Sometimes this error message will be way longer, many rows. You always start from the bottom up. That's where the most specific error message is. And then from there you can find, okay, so this is the error, name error. And where is it? And then it says it's in this file on line 1. And this is exactly, it even puts this little thingy that looks like arrows, okay, to show you where is the problem. It doesn't always tell you, okay? It doesn't always know exactly where the error is. And because sometimes it says, oh, there is an error here, but the error happened earlier. It just noticed it later. So the errors will be on the line, on the place where it points, or a little bit earlier. Python is quite good at actually already pointing you to the right place. So here, what we did in the code is I put foo. I wrote foo, but because I didn't put it in these quote marks, Python thought that this is another variable, let's say, or function, or something like this that should exist. And it says, well, it doesn't exist, and it's called name error. So these things are called, all of them are called names. Variable name, function name, or all kind of other things can have names, okay? And it says, okay, there is this foo thing, and I have no idea, it's not a Python name. And no, it's not a Python name, it's just some random text. And if it's some random text, then I have to put them into quotation marks. And I can use double quotes for this. That's the usual thing that people use. Okay, so now I put the value first name in this, and I can take it and print it out. Print, and of course I have to, now again, okay, it's the curly. Why? Because it's still the earlier variable name, the word name. If I go back to the command line and run it again, now it complains about that. It says the same thing. Okay, I have no idea what is this name thing. So no, it's called first name, right? Good. Now there are no curlies. If I go to the edit terminal and I run, it says foo. Okay. But what I really wanted is to say, hello, foo, how are you? Okay, something like this. So I would like to say this, hello. Then I would like to print the name, the first name. Let's put it this way, comma, how are you? And end of the, oops. I pressed something and I didn't like it. No, I don't need this one. Double quote. Okay. So what happens now? It prints out, oh, yeah, I made an error. Okay, so let me show the first one. This is very confusing when I use two languages and they work slightly differently. But I will show you the other one as well. Okay, so this is one way to do this. Okay, so you can see the result is hello foo, how are you? So I have this variable first name, and here I have a string and this pair of curly braces, and no one told me that you can't see the letters, but I can't see them. Okay. If it bothers you that it takes up space, then you just click on the thingy and it disappears. Okay. So the pair of curly braces is a placeholder, and then we can say dot format and provide the name of the variable. But actually, and I will leave it here, but I show you a much better one, the one that I started to write, but I forgot one small part of it. So I can put it here. Okay, this won't do the job. So, but I keep it here. So we'll have it comment in the examples. The right way is to put a letter F here, because it's called an F string. Okay, so what I have here is a string preceded with a letter F. It's F string because it's formatting string. Okay, it's a feature of Python that allows me to put variables in curly braces inside the string and get the value of the variable instead of the text. So now if I run this, you will see that the first one is the hello, who are you? The second one is this problematic one where I mistakenly printed out the placeholder itself and the name of the variable. This is not what I wanted, but I will leave it here for now so you will see it, okay? And I even put a comment here. I'll put it in a second. The third line is again the right one. So you can see it put in the value of the variable here. So this is how you can show some text and include the value of some of the variables. Okay. I can put a hash mark here, and whatever comes after the hash mark is going to be a comment. Okay. Forgot to add F. So this prints the name of the variable. Okay, and this is the F string. Okay. Let's save it and let's run this again. Okay, everything works fine. The things that I wrote at the end, they don't show up. They don't make any difference for the program. So what are these? These are what we call comments. In Python, in different languages, you have to mark them in a different way. In Python, if you put a hash mark, then whatever comes after the hash mark is going to be a comment, which is basically disregarded. And these comments can be really useful for explaining why you are doing something the way you are doing, or sometimes even what you are doing in the code. The point here is that the point of these comments, well, you can see here now that I was trying to explain why we have this code here in the examples. The point is that you have to come back to your code later on, and you have to figure out what did you do, why did you do, and so on. And these comments can be really, really useful if you're writing them in a way to be useful. Actually, I think we're going to have an exercise down the road, like 5-6 weeks from now, to come back to one of your exercises earlier and try to understand what did you do. Okay, it's a good exercise because it shows that, well, probably that that you think that what you did 5 weeks ago, it was horrible. Now you will know much better. So it shows you progress. That's great. One of the points is that when people are talking about programming, even when you study computer sciences, as I did, and whatever, they think, or they sort of pretend, or I don't know, what is that understanding, that your job, the main job, is to write a program. Research shows that anyone who is doing programming, okay, and you're going to do, even if it's not your main job, 70, 80, 90% of their time, they're trying to figure out what is written there in order to make some improvements, or to fix some things, or add some new features. And it might be code of someone else, or it might be your code that you wrote a month earlier or a year earlier. And so this means a couple of things. One of them is it's being able to read code is maybe more important than being able to write code. And being able to write code that it's easy to read, it's really, really important, right? And these comments can help. But you have to be really, really careful with comments, because sometimes, how can I put this? So the thing is that you write some code, you explain it, and then maybe later on you go on, improve the code, change the code, and you forget to change the explanation. Now you have an explanation that's incorrect. And that's way more confusing than having no explanation, probably, because then you come back again a month later, 2 months later, and you see and you don't understand this is why is the explanation this and why is the code doing something else. Because you will forget. I mean, a couple of months, maybe a year later, who remembers these things? I mean, I don't. Okay, so now we know how to write a program and print some variable, the content of the variable. But obviously, not everyone is called foo. So what can we do in order to greet some random person? And before I go on, I think I will create a new file, and I will actually save this one as hello foo, because this is the hello foo, and the hello person needs to ask a new person. So I'm going to save this file and say save, where is save as here? Save as, and it's called hello foo. Okay, so now I have the hello foo here. I don't need it, and I would like to open the hello person, right? Now I would like to show you 2 ways to easily open it. One of them is that you go here, click on this one, the Explorer, and then you find the file and double click on it and you open it. That's sort of, okay, easy. There is actually a better way that's probably better for especially bigger programs. I press Control P, the letter P. It opens, and Visual Studio Code has tons of these features, a search bar, and then I can type in, start typing in some part of the name that I remember, okay? It doesn't have to be the beginning. I think it doesn't even have to be a consecutive PR. Yeah, you can see it finds file names that have P and R in them, okay? So it's, especially if you have a project with many files, and a hierarchy of folders and whatever, you won't remember where they are. So it's easier this way to find the file. Okay, of course, this one is also working. So let me put this, before I forget, VS Code, Control P to open a file. Okay, I just have this note because I will forget this specific thing. Hello person. Okay, so now it's not first name, it's someone, it's not foo. How can I ask the user? And there are basically 2 major ways to get input from the user. One of them is when you start running the program will ask you questions. And this is what I'm going to show you. The other one is that you supply all the answers up front. You'll see that later. In Python, there is this function called input that gets here a parameter, which is a prompt text, okay? And it doesn't actually need it, I think. You can do this way. Okay, let's try this one. Okay, and I don't need this the middle one. I showed already that I know how to break my code. I don't even need this one because it's enough the F string. Okay, I don't need this comment anymore. Okay, so I'm going to ask the user the name and then print it out. Let's run this. Python, hello person. Enter. It doesn't show you anything but we know that it's asking for the name. So let's call me Gabor now. Okay, so it says, hello Gabor, how are you? Looks not good, but I didn't really like it that it didn't ask me any question. It was just waiting. Okay, that looks strange. So what I can do is put in this input some question. Okay, Okay, what is your name? Good. So I run it, and now it says, what is your name? And now I type in Gabor, and now it works. Okay, so this way I can ask the user all kinds of questions, and then based on that, I can have some behavior. Any questions besides my name? Okay. So let's implement a calculator now. New file. I'm going to save it as calc.py. So what is how do a calculator work? Okay, I ask, let's do, well, it's not even a calculator. I didn't want to do a calculator. I just wanted to add a function, a program that can add two numbers. Okay, it's a calculator, very simple calculator. So we ask the user for two numbers, and we would like to add them. So how do I ask it? Well, let's do it way more complex. Let's do ask for the length and the width of a rectangle and calculates the area of the rectangle. Okay, so we don't add, we multiply. Much more interesting. So we ask the user, what is the length? And we are going to put it in a variable called length. Input, and we ask length. And that's it, fine. And width equals to input, not good, width. I just realized that my idea wasn't good. I need to add them. Okay, so for now, let's add them. Okay, and then we'll multiply them later. So what is the, if we add the length and the width, what do we get? Some number. Okay, it doesn't really, doesn't make any sense. We need a better example where I need to add two things. Okay.
Why this one is not good?
You will see. You will see. You will see. This is not because it shows. Oh, wait a second. It shows. It shows a different error. I want to show you one error, and that will show you a different error, and the more complex one. Okay. So I'll rewrite it, but I will get back to this one later. Okay. So what I started to do is I highlighted the text and I pressed Ctrl/, and it automatically commented out both lines. Yeah, I know I didn't save a lot of work. I could have done this. Okay, I could have just come here and press myself this. Okay, because these are just two rows. But I'm quite used to highlighting it and pressing Ctrl/. Okay, this is again a feature of Visual Studio Code. So I'm going to add this. Where is this? Yeah. Highlight and press Ctrl/. Okay. To comment out rows. Okay, so I just a couple of these things. Now, by the way, if I highlight it again and press Ctrl/ again, it removes the comment. Okay, so let's start again. First input, first number. Of course, I forgot the quotes now. You see, this is, what if I, yeah, okay. I can highlight the text and then second equal input, second number. Okay, so then sum, first plus second, right? And then I print the sum. I can even see, the sum is, and it keeps wanting me the Python interpreter, and I don't want it now. Okay. So what happens now? Python calc. First number, 2. Second number, 3. What I'm going to get back as a result? Nah. Error, because I forgot the, not error, I just forgot the F again. Okay. So, F. Let's try it again. 2, 3. Okay, I know it sounds too basic a question. Well, the answer is 23. Why is it 23?
It refers to the text and not to the number.
Right, right. So, depending on programming languages, inside a computer, they look at data in different ways. And especially they separate text and number things, okay? Actually, Python separates text, integers, and floating point numbers, so the ones with the decimal point. Other languages have way more separations. They have different numbers, different integers, small integers, big integers, very big integers, integers that can have negative numbers or can't have negative numbers. And you have to deal with all that detail. In Python, you don't have that much detail. You only have integers, floating points, so decimal points, and text, or we call it strings. And the interesting part is that whatever you get from the user, okay, even if you asked for a number and the user typed in something that looks like a number, right, the number 2 and the number 3, in reality, Python always receives them as strings. Okay, it doesn't care about the fact that they are actually look like number. Okay, so when we put this first plus second, what it did, it concatenated the two strings. So we get the string 2, 3, which looks like 23. Okay, so if we go back to the screen, it looks like 23, but Python also only understands it as the string 2, 3. So in order to make it correct, okay, let me copy this whole thing, so we'll have both of them. I need to convert them into numbers. And we have 2 functions for this. One of them is going to convert them into integers. And right now, I'm expecting them to be integers. Okay, so this doesn't change at the variable first and the variable second. They themselves remain strings, but they take, both of them, in both cases, they take the content of first and second, they convert the content into numbers, use these numbers for the addition, and then forget about this whole conversion thing, okay? So after this, first and second, they're still strings. 2, 3, okay. So the first one is still looks like 23. The second now is 5, as we are expecting. Okay? So, good. What happens if I give it some more interesting number? 2.1 and 3.1. Uh-oh. It says invalid literal for int. So we're trying to convert a string, right, the string 2.1 into an integer. And Python says, well, I can't convert it to an integer because there is a dot in there, and integers don't have dots in there, right? So it blows up. And this is an error that we get while the program is running, right? This is called a runtime error that we saw earlier, a couple of these runtime errors already. Okay, What can we do here? I copy paste. And I put this in comment for now because it won't work. Here, instead of int, I put float. Float will take whatever string you give it and convert it, or tries to convert it, into a floating point number. So a number with decimal point. If I run this code again, and I type in 2.1 and 3.1, I get, well, the concatenation is now really, really strange, of course, because it's still strings, so it's concatenated. But here, when they are floating point numbers, then it works. And what if I run this and I give 2 and 3? That's fine. It just says that it's 5.0 because it's a floating point. So it tells you that there is nothing after the decimal point. Okay? Any questions here? One more thing before we go to the break. What happens if I run this and now I type in foo and 3? It will blow up again while the program is running with a value error and say could not convert string to float foo. As here it was invalid literal for int, right? It couldn't convert this one. It says it can't convert to float, this thing. So neither int, of course, would be able to convert this into integer. And this blows up the program. And ideally, when I get an input, ideally, I would never want this to happen. I would never want the program to crash, basically. I would want to tell the user, let's say, oh, I was asking for a number, floating point number, but you gave me a string. Don't do this. Because if the user sees this, the user will definitely say your program is broken. Even though the user is the one who typed in a text while you were asking for a number. Okay, so even for that, it's important to be able to give a good error message and not let Python blow up, because it doesn't look good. But we'll have to wait a little bit more, a couple of more weeks till we learn how to deal with that. So for now, you just convert it, try to convert it, and if it can't convert, then it will blow up this way. It will crash, or the proper way to say this is it through an exception. Any questions? Okay, so let's have 10 minutes break now till 11, and then wait a second. One more thing before I forget. Important. We go to the git bash, git status. Okay, all these files, git add readme. Okay, I can convert git add dot, git status, git commit -m, add more examples, and git push. Okay, that's it. Now now we can have a break, and you can see the examples already on GitHub. So see you in 10 minutes.